All right, I'm only going to do one of number 18 because they all will work out in the exact same way. So I will do 18, um, just the first one. I'll just do the original 18 because all the other ones are totally the same exact process. So I'm not going to do a video for each because it's the same each time. So consider the rectangle bounded by the x-axis and the function y equals 121 minus x squared. Sketch a picture of the graph. Include any major points. So let's sketch this graph. You should be able to graph this by hand. 121 minus x squared. Y equals 121 minus x squared. Maybe you like looking at that as y equals negative x squared plus 121. So you should know, because there's a negative in front of your x squared term, that this parabola will be upside down. So it's going to be like that. And this plus 120 blah 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 plus 121 is your y-intercept and the y value of your vertex. So my vertex is up here at 121. And then my parabola, since I don't have like an x plus 5 or anything like that, it's centered on the y-axis. So it's going to come down on both sides with perfect symmetry. And I know that those x-intercepts are going to be 11 and negative 11. And I know that because if you wanted the x-intercepts, you would set y equal to 0. So you could have 0 equals negative x squared plus 121, and then you could have x squared equals 121, and x equals plus or minus the square root of 121, which is plus or minus 11. So if we want to then really picture this situation, what we're saying is we have some rectangle in here that looks like that. Its base lies on the x-axis, and then its top two vertices lie on the parabola itself. So if you think about this situation here, what we want to do is we want to label this point here x, comma, y, generically x, comma, y. Because then if that point is x, and since I know this parabola has perfect symmetry, I know that this distance is x, which means that this distance is also x, which means my total base is 2x. And since this vertex right here, that point, is on the graph, I know that the height of that point is just y. But even better than just calling it y, I know that y is 121 minus x squared. So if you think about the diagram here, what we really have is we have 2x along the base, and then we have y along the vertical axis. But instead of y, I'm going to write 121 minus x squared, because now I only have one unknown value in my diagram. So if I want the equation for the area of a rectangle is the base times the height. Well, my base is 2x, and my height is 121 minus x squared. So I have an area equation in terms of x. And I want to know, what is a practical domain? Well, x is talking about this distance right here. And that distance cannot be greater than 11, because if it were 11, we would just have like a straight line right there on the x-axis, and my rectangle would have no area. So for a domain for this function, all I need to do is look between 0, maybe even just call it a parenthesis, 0 up to 11, like that. So that would be a practical domain for x. What is a good window to see the whole function? Well, to see the whole function, what you should do is you should go to x min on your window, type 0, x max, you should type 11, and then you should hit zoom, and then you should hit 0 to get a zoom fit. This will give you a perfect window for this graph, because this 0 represents that x-intercept right there, and this 11 represents that x-intercept right there. So this is a negative cubic function, which means it's going to look like, if you think about this, we will have, like we said, an x-intercept at 0, and we will have an x-intercept at positive 11 and negative 11 as well, because 121 minus x squared has solutions at 11 and negative 11. So if it's negative, it means it's going to look like this because it's a negative cubic function. So all we are interested in is this bit right there. So by choosing those two x-intercepts, and then hitting a zoom fit, it'll adjust our window so we see perfectly right this section right here that I've just boxed in, this pink section right here. Zoom fit will give us that perfectly, or I guess realistically, it'll give us that. So enter your equation into y1, x min 0, x max 11, zoom 0 gives you a zoom fit, and then you should get a graph that looks like this. It's going to go from 0 to 11, and it's going to come up and look something like that, kind of like an off balance parabola almost. So again, it does give you a perfect window, and it makes that maximum y value the value of the vertex, which is what we're trying to find, which is kind of sweet. So on my calculator, it made that y value 1024.56. So perfect window would be these dimensions right here. But we should probably actually calculate the maximum rectangle. And when you do so, my guess is that we're going to get exactly 1024 for that y value. So let's go second trace, and then choose option 4 for the maximum. Left bound, I'm going to hit 0 and hit enter. Right bound, I'm going to hit 11 and hit enter. And then for guess, I'm just going to hit enter. And it will think for a minute, and it will give me 1024.6043. 1024.604, and that would be my area. If I wanted to know my dimensions, the corresponding x value is going to be the x dimension. So it tells you x equals 6.351. If I wanted to know the corresponding y dimension, I would need to plug that x value into my original parabola equation, 121 minus x squared. And when you do so, you get 80.666. Now, if you listed this as your answer, you'd be incorrect, because those would not be the dimensions, because the base of our rectangle is 2x. So I actually need to be double that 6.351, which means I'm actually going to be, if this is my rectangle, the base is 12.702, and the height is 80.666, giving me the maximum area of 1024.604 right there. And then the last question says, what x values will result in an area of 150? Well, that means that 150 is a y value, and we want to know what's the corresponding x value. So on your graph, what you should do is you should graph the line y equals 150. That will give you a horizontal line on your graph like that, and you can calculate these two intersection points. So then do that, and then go back to your graph, hit second trace. Option 5 is intersect. First curve, enter. Second curve, enter. Guess, enter. It'll take you to the closer intersection point, and you will get x equals 0.622 as this solution. And then do it again. Second trace, option 5, enter, enter. Now make sure you're closer to the other intersection point. So for guess, I'm going to type 11. And it's going to take me to the other one now, and that will give me x equals 10.676. So those would be the answers to part E. Find the maximum area of the rectangle. We found that. We say the dimensions as well. If it asked a question like, what is the area when if x is 12, then all you need to do is on your graph hit trace and type 12, and it would tell you the corresponding area if 12 was in the domain. Now 12 is not, so that's a bad example. Let's say, what is the area if x is 3? We'll hit trace, type in 3, and you will get a corresponding y value of 672. So if x equals 3, then the area is 672. And you should be able to answer a question like that as well. So I'm not going to do the videos for the other ones because it will work in exactly the same way. So practice those a little bit, make sure you're comfortable with it.